Question 3 is coming from complex numbers, in particular, locus of points. The shaded region on the Argand diagram shows points representing complex numbers z defined by two inequalities. The shaded region is bounded by a circle, a line parallel to the real axis. Then the boundaries of the region are included in the shaded region. Find the two inequalities in terms of z that are defined that define the shaded region. Usually we have always been given the inequalities and then we sketch them. Now they have given us this one is sketched and we are told to find the inequalities. Now this one is a circle, and for the circle we have the general formula in this locus of points z, then minus, we have something like a plus b I, okay, and this becomes the center. And since this one here is a bold circumference, that means all the points that are on the circumference of this circle, they are considered, and okay, they are considered, and those points are these 3 units. The radius is 3 units. There are 3 units from that region. So that means generally, if the circumference of the circle is inclusive, then we say less than or equal then to that r. But if it is only inside the circle, then we remove the equal signs. Okay, then if it is only the circumference and it is just that, not inside but just on the circumference of the circle, then we have equal signs here. Now this one here is a circle of center, a, b, and radius r. So looking at what we are having here, minus the center here is -2, 1. So we shall have -2, then plus the I, then less than or equal to the radius is 3. Okay, 1, 2, 3. Radius is 3. And then I can actually simplify this and write z, then plus 2 when I open the brackets, minus I, then less than or equal to 3. So this is one inequality. Then the other, we are seeing this this bold line here. It is this line here is horizontal, so it's like y is equal to something. Okay, but now here we don't use y, it is imaginary of z. So meaning we can have imaginary of z, okay, let's say is equal to -1, okay, which is -I. I may write I or -1, but better write the values, since this is already on the imaginary axis, so we don't write that I can say -1 here. Now, but that is the line, but you can see that what is shaded is a region that is below. Okay, it's a region that is below, and the line is also bold. Since the line is bold, then that means I'm going to use the less than or equal. So I will have less than or equal to -1 here. So this is going to be the next inequality. Then part B, find the greatest value of the magnitude of z for the points in the region. Now here we are going to look at from the center here. So actually it is from the origin here, then we connect, we are drawing lines to these points here in this region, and then which one gives the what? The greatest length, because we are having modulus here, it is about the length. So which one do you think gives the greatest length? I think it has to be this first one here. It has to be this one here. The rest are going to be smaller lengths. Now, I need to find that region, but I don't know where these two are meeting. Okay? So since I don't know where these two are meeting, there are many ways you can do this. I can actually begin by connecting this point to the center here. Let me actually make it a little bit dotted. I can begin by connecting this to the center, then I also connect it to this one here. Let me also make this one dotted. Then when I do that, of course, this one is a right-angled triangle. So these are 2 units here. And how many units do we have here? Now this one here, these are 3 units. Okay, those are 3 units. Why? Because this is the radius from the center to the circumference. These are 3 units. So if I pull out that triangle here, we have 2 units here, we have 3 units here. That means this one here is going to be, using Pythagoras theorem, it will be 3 squared minus 2 squared, which is going to be 9 minus 4, that is 5. So it's the square root of what? Square root of 5. Now, I have this region here. I have this region here. This is 1 unit. Okay, this is 1 unit, and I have this one here as root of 5. Let me put this one in red, root of 5. Okay, to move from here, that is all, root of 5. But then here there are 2 units. You see, these are 2 units. You can see this is -1, this is -2. So those are 2 units. Now, if those are 2 units, that means this whole triangle, we are having 2 plus root of 5. So I will have this triangle here. This is 2 plus root of 5 in length, and this is 1. Okay, so that means I can be in position to calculate the length of this one here, which I'm looking for. So meaning I will have my greatest value of modulus of z is going to be the square root of 1 squared, then plus 2 plus root of 5 squared. Okay, and then when you put this one in the calculator, what do you get? Square root of 1 squared, then plus 2 plus root of 5. Then we also square that one, and it will give us 4.35. Okay, they didn't say exact and what, so I can leave it as 4.35. Okay, or if you want to expand this one, it can actually be 1, then plus square the 2, that is a 4, then plus 2 times 2 times root of 5, that is 4 root of 5, and then square the root of 5, you'll get a 5. Okay, so meaning you will have here 5 plus 5, that is 10. So this one is the same as square root of 10, then plus 4 root of 5. So exact is this one here. Now, alternatively, we can find where these two meet, this point and this point. We saw them simultaneously. Now, this is what we are going to do. Because we have our equations, so those are the ones that we can use. Instead of using imaginary of z, which is equal to -1, I'm going to have, because that is a horizontal line, I can say y is equal to 1. Then the equation of the circle, you know, the general equation of the circle is x minus a, then squared plus y minus b squared is equal to r squared, right? So we are going to have this one for this circle. It is going to be, remember the center is negative 2, 1. So we have x minus minus 2, so that will be a plus 2 squared, then plus y minus 1 squared, and the radius we have seen it is a 3, so we shall put 3 squared. Now by putting this one here, okay, y is equal to negative 1, which is not 1. So by putting this one here, you will have negative 1 minus 1, and then you will get negative 2. So we have x here squared. Okay, let me first write x plus 2, then squared. Then this is negative 1 minus 1 squared, which is equal to 9. Okay, now this one is going to be x plus 2. Let me leave it just like this. This one will give us a 4. Then I take it this side. 9 minus 4, we shall get a 5. Then take the square root on both sides, so you will get x plus 2, which is equal to plus or minus the root of 5. Remember, when you take the square root, you get plus or minus, and then you take the 2 the other side, it will be negative 2, then plus or minus the root of 5. You see? Now, when you look at that triangle, there are two x values. You have one x value, which is negative 2 minus root of 5. When you look at this one here, the negative 2, remember, it is on the left here. So that is negative 2 here, then minus root of 5. So this is the whole thing. But when it comes to lengths, we shall ignore the negatives. Okay, so that means this whole thing is 2 plus root of 5. It would have been negative, but we are dealing with lengths, so I ignore that negative. And there is a 1 here. Okay, so, and you can see that we are having the same thing as here. So meaning that greatest value of z, okay, is going to be that square root of 2 plus root of 5 squared, and then plus the 1 squared, which gives us the same answer as square root of 10 plus 4 root of 5.